Welcome to the DIY Honda Garage channel. Diagnostic Trouble Code DTC P0443 indicates an issue with the EVAP Canister Purge valve circuit. The EVAP, Evaporative Emission Control System, purges fuel vapors from the charcoal canister into the intake manifold, helping to reduce harmful emissions. Specifically, this DTC points to a malfunctioning circuit related to the purge valve, which may be either stuck open or closed. This malfunction can affect vehicle emissions and performance, making it crucial to address. The EVAP canister purge valve is typically located in the engine compartment and is connected to the vehicle's powertrain control module, PCM. Early detection and proper troubleshooting steps can help prevent more extensive repairs in the future. The EVAP canister purge valve plays a vital role in managing fuel vapors produced in the fuel tank. By allowing these vapors to be routed into the intake manifold, the valve supports the vehicle in meeting emissions regulations. The purge valve is situated in the engine compartment, connected via hoses and electrical connectors to the PCM. The PCM is responsible for regulating the operation of the valve based on vehicle operating conditions, ensuring optimal performance and compliance with emission standards. If the circuit malfunctions, it can lead to a rise in harmful emissions and may trigger a dashboard warning light, indicating the DTC P0443 should be investigated. Understanding its function is crucial for effective troubleshooting and repair. There are several possible causes associated with the DTC P0443. One primary cause is if the EVAP canister purge valve is stuck in the open position, which may lead to an excessive flow of fuel vapors. Conversely, if the valve is stuck closed, it restricts vapor flow, causing the system to malfunction. Wiring issues can also contribute to the problem. Damaged or shorted wires between the EVAP valve and the PCM can disrupt the entire circuit. Loose or corroded connectors might lead to intermittent connectivity, exacerbating the DTC. Proper diagnostics will help pinpoint the exact cause, whether it's mechanical within the valve or electrical in nature. The presence of DTC P0443 can exhibit various symptoms. One common indicator is the illumination of the check engine light on the dashboard, alerting the driver to the need for vehicle inspection. Additionally, because the EVAP system is responsible for managing fuel vapors, failure of the purge valve can lead to increased emissions, which may affect compliance with environmental regulations. A malfunctioning valve may also lead to poor engine performance, such as rough idling or decreased fuel efficiency, which is something drivers may notice during daily operation. Monitoring these symptoms is essential for identifying the need for immediate troubleshooting to avoid further vehicle damage. The first troubleshooting step involves verifying the problem by turning the vehicle to the on mode. The Honda Diagnostic System, HDS, is then used to clear any existing DTCs from the vehicle memory. Following this, the engine is started and held at 3,000 RPM without load until the radiator fan activates. Then, it is allowed to idle. This procedure helps to regenerate normal operating conditions. After this, the HDS is used again to check for the presence of either pending or confirmed DTCs. If DTC P0443 appears again, it confirms a persistent issue that requires further investigation. If it does not appear, an intermittent failure may have occurred, and a detailed inspection of wiring and connectors should be considered. In troubleshooting step 2, the vehicle must be turned to the off position, allowing the engine to cool. The next action is to remove the EVAP canister purge valve while keeping the connector and vacuum hose attached. After safely detaching the vacuum hose from the purge valve, A vacuum pump and gauge are connected to the purge valve in the engine compartment. The engine is then restarted and allowed to idle. Monitoring the vacuum pressure at this stage is crucial. If there is vacuum present, it indicates that the purge valve is stuck open. Conversely, a lack of vacuum suggests that the valve may be stuck closed, which directs the technician to proceed to the next relevant troubleshooting step. Understanding these indications allows for an effective troubleshooting direction. Step 3 requires turning the vehicle off again to prepare for a continuity test. The technician must disconnect the EVAP Canister Purge valve's 2P electrical connector to examine the electrical integrity of the circuit. Continuity is then tested between designated test points, specifically between the terminals of the purge valve connector and body ground. This test ensures that electrical signals can pass without interruptions. If continuity is detected, it leads to the next troubleshooting step. If not, this indicates that the EVAP canister purge valve is faulty and should be replaced. Proper continuity inspection is essential for ensuring that electrical components function correctly and helps narrow down the failure point. In Step 4, a short circuit check is performed, beginning with the technician jumping the SCS service check signal line with the HDS. After a brief wait of over a minute, the next step involves disconnecting the PCM Powertrain Control Module Connector E, which consists of 80 pins. Continuity is then checked between the specified test points in the disconnected state. This test helps identify any short circuits occurring in the wiring leading to the purge valve. If continuity is found, it indicates a wiring fault between the PCM and the EVAP canister purge valve. In such a case, repair of the shorted wire is recommended. Failure to find continuity suggests further investigation into other system components or wiring integrity. Step 5 includes assessing for possible open circuits in the wiring. The technician selects the vehicle's on mode to perform voltage checks. By measuring the voltage between defined test points at the disconnected EVAP canister purge valve 2P connector, the technician can determine whether battery voltage is present. This measurement is critical. A positive voltage reading suggests that the wiring is intact, but may also indicate issues further down the line. Conversely, if battery voltage is absent, it indicates an open circuit in the wiring connecting to the number A37 fuse. Repairing this open circuit should then be the subsequent action. Understanding the voltage readings can provide crucial insights into the electrical health of the system. The 6th troubleshooting step mirrors previous wiring continuity checks but focuses on the PCS, Purge Control Signal Line. Following the same procedure, the technician jumps the SCS line with the HDS and disconnects the PCM connector E again to isolate the circuit. Continuity is then tested between the EVAP canister purge valve 2P connector and the designated PCM test points. Finding continuity here indicates that the wiring is functioning properly. If not, it suggests an open circuit exists in the wiring. Repair of this wiring fault would then be necessary, while understanding that proper continuity is essential for effective operation of the EVAP system. In the final step, attention focuses on assessing the internal resistance of the EVAP canister purge valve to determine its functionality. With the vehicle in off mode and the necessary connectors removed, the resistance between designated test points is measured. The ideal resistance value should be approximately 23 to 26 ohms at room temperature. If the resistance readings fall within this specified range, it indicates that the EVAP canister purge valve is functioning as intended, allowing the technician to pursue authorized service information if necessary. However, If resistance deviates from this range, it suggests malfunction, warranting replacement of the purge valve. This resistance check is critical for validating the operational integrity of the valve. Once all necessary repairs have been completed based on troubleshooting findings, it is essential to verify the effectiveness of the repair. The technician should begin by clearing any remaining DTCs from the PCM using the HDS. A follow-up test drive is crucial to ensure all systems are functioning optimally. During this test drive, the technician should monitor for any recurring symptoms or warning lights associated with DTC P0443. If the check engine light remains off and the vehicle operates smoothly, this indicates successful resolution of the issue. Documentation of repairs and verification steps is also a best practice, contributing to thorough and transparent vehicle service records. Preventive maintenance is key in avoiding future occurrences of DTC P0443 and ensuring the longevity of the EVAP system. Regular inspections of the EVAP system, including the purge valve and associated hoses, can catch issues before they lead to problems. Maintenance of the vacuum lines is particularly important. Cracks or leaks in these hoses can cause malfunctioning of the purge valve and lead to emissions issues. Additionally, monitoring the condition of electrical connectors can prevent loose or corroded connections that may disrupt communication with the PCM. Following these preventive measures can contribute significantly to the reliability of the vehicle's emissions control system. In summary, understanding the EVAP system and the role of the canister purge valve is essential when dealing with DTC P0443. Following the structured troubleshooting steps ensures that every aspect of the issue is thoroughly investigated and informed decisions are made regarding repairs. Additionally, implementing regular vehicle maintenance procedures, such as checking vacuum lines and electrical connections, can reduce the risk of future DTC occurrences, ensuring that your vehicle runs efficiently and remains compliant with emissions regulations. Ultimately, prioritizing both troubleshooting and preventive maintenance contributes significantly to a vehicle's long-term health and performance. Please like and subscribe to the channel. See you next time.